draw two intersecting lines, that's important, two intersecting lines on our paper, and we compare angle 1 with angle 3. We notice that angle 1, I traced it right here. I'm going to bring it over here, and I'm going to compare its measure, whoa, with angle 3. And I notice that those angles are congruent. But you said some great things. You said they're congruent. You said their measures are equal. You said they're the same. That's awesome. You remember how we mark that two angles are congruent? Because like for segments, we add tick marks when they're congruent. What do we do for angles? Yes, I call it an arc. We add an arc to our picture. I sound like a seal. Arc, 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 arc. Anyway, add an arc to the picture to show they are congruent. Some people add tick marks to the arcs, but I actually, when I've already used a single arc, let me trace this one and confirm. I just want to make sure. Angle 2, how does it compare with angle 4? Oh, perfect. All right, so I've confirmed. And when I have already used up one arc, I use a double arc the next time. So I don't really do the tick marks on the arcs things, but sometimes people do that in textbooks and stuff. So we need to make a conjecture. We found out that angle 1 is congruent to angle 3, and the measure of angle 2 is congruent to the measure or equal to the measure of angle 4. What are those angles called, by the way? They're a vocab word. What are 1 and 3 called? What are 2 and 4 called? Yes, good. They're called vertical angles. So I want you to write this down in your notes. It's called the vertical angle theorem. Our goal is to learn 2 theorems today and use 2 theorems. Not bad. Discover 2 and use 2. 2 theorems. We can do that. Vertical angle theorem. If 2 angles are vertical angles, then they are congruent. That's an if-then statement. Remember, it's called a conditional. Conditional. If 2 angles are vertical angles, then they are congruent. So, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And when you mark all of them, it looks like a flower or rose or something. Now, to be able to talk about vertical angles being congruent, we need to be reminded what vertical angles are. This is on your vocab sheet, so you are not writing this down. Vertical angles are the opposite angles formed when 2 lines intersect, or 2 lines cross. So we've got 2 lines, they're crossing. We've got angles that are formed, 4 angles, right? But the ones that are vertical are the ones that are opposite each other. So we need to be careful. There are the angles formed when 2 lines cross. And I'm afraid that this angle and this angle, they're not the opposite angles formed when 2 lines cross. There's 4 lines making those angles. Do you kind of see? I needed this one, I needed this one, I needed this one, and I needed this one. That's 4 lines. So those are not vertical angles. And then right here, we don't have vertical angles once again because there's like too many. Oh, I see, you use these 2 and you're trying to do this. Those might have crossed behind the flag, but we need to be careful. The moral of the story is, when you're looking for vertical angles, you're looking for the letter X. Because if you can find the letter X, then you can find vertical angles. And here they wouldn't go all the way past as mine did. If you can find the letter X, then you can find vertical angles. In this picture, we had a lot of trouble with this picture. But that's one example of vertical angles. Be careful where you put them. Now this one, I'm not sure that's a perfect X. So that looks like that segment is almost bent, so I'm not sure that those are vertical angles. Here we've got an X, right? So they're the opposite angles formed when 2 lines cross. And we talked about those were just really bold lines. So we're now going to see in pictures that are not real world pictures if we can find which angles are vertical And which angles are pretending? They're not really vertical. So I'm going to say it again until you get tired of me hearing it. Vertical angles are the opposite angles formed when two lines cross. And the two lines will kind of look like the letter X. So here, we've got the letter X. These are opposite angles. You're vertical. You win. Awesome. Here, we have two lines crossing, opposite angles. Do we care about that other line in the picture? That doesn't really affect us. That doesn't change the fact that those are vertical angles. Here, this is not the letter X. What letter is that? It's like the letter K sideways, right? Or a V in a line. Anyway, this is three lines crossing, people. That means that it can't be vertical angles. They are not the opposite angles formed. 1 and 2 are not opposite each other. 1 and this one are opposite each other. Okay, check. 1 and 2, opposite. Very good. Here. Do I get the letter X when I make those angles? No, I get the letter K again. A capital K, because you're not vertical angles. And then here, these almost look like vertical angles. And the tricky thing is here, these actually are congruent. Those are the same measure, but we're going to learn about those angles next unit. And because they're not sharing a vertex, because they're not opposite in not only 2 lines, we have 3 lines involved, then they are not vertical angles. This is already in your vocab notes. Adjacent angles are angles with a common vertex. Let's stop right there. What does that mean? A common vertex, so I'll call it A. Angles 1 and 2 both have vertex A. They even have a common side. Now, what is the side of an angle? What vocab word? Yes, so a common side, aka a common ray, and no common interior point. So, angle 1 is not getting in angle 2's business. Although they share a ray, they don't share anything on the inside. So they are separated by that ray that they share. So adjacent angles, 2 angles with a common vertex, a common ray, but no interior points in common. I want you to look at this picture, and in your notes, I want you to write a pair of angles that are adjacent, and write a pair of angles that are not adjacent. Do that in your notes, please. All right, so we have AGB and BGC. Here's how you name an angle. So we put the angle symbol and then 3 capital letters. So you're talking about AGB. So you're saying that this angle is adjacent to, Is that what you typed? So although this wasn't what the student wrote because I wrote it down wrong, would these 2 be adjacent angles? This one and this one. But they're sharing a ray. They're sharing one ray. They're sharing a ray. But why are they not adjacent? They have interior points in common. Very good. Okay, what the student really wrote was AGB and BGC. And so, yep, those angles, angles 1 and 2, those are next door neighbors. They're sharing a fence. They're sharing a ray. They are adjacent. Let's name another pair that are not adjacent. So let's start off with that same angle, AGB. And let's name one with vertex G that's not adjacent. So we could even skip over a little bit. We could do C, G, D. So angle 1 and angle 2, they're almost next door neighbors. They're close to each other, but they are not adjacent. Okay, let's move on. Here's some vocab words that we already went over last week, so I'm going to breeze through these. These are already on your vocab sheet. Complementary angle, 2 angles whose measures have a sum of 90. The angles can be complementary and separate, or they can be complementary and adjacent, like in that picture. Notice, The angle by itself is not complementary. A right angle is not complementary. Complementary angles have to be two angles whose measures have a sum of 90. Very important. Supplementary angles, we can have them separate. We've got two angles whose measures sum 180 degrees. Or, here's what it looks like if they're supplementary and adjacent. So they can be separate or they can be together. But also, once again, supplementary, a straight angle is not supplementary by itself. It has to be two angles. Let's practice naming the complement and supplement of these angles. We're going to go quickly through it so that we have time. What's the complement of 15? Nice. Well, 75, yeah. What's the supplement of 15? There you go. 165. So what are you doing to find the complement? How do you find the complement of an angle? Subtract from 90, right? You do 90 minus the angle you're given. How do you find the supplement of an angle? Of course, 180 minus the angle you're given. So if we did that one, that one was already in the picture, right? And then the other one would be, name me an angle that would not have a complement. Name me an angle that would not have a complement. 91, 96, 40 would. Anything greater than 90 would not have a complement because we don't deal with negative angles. All right, I'm showing you a picture of a linear pair and a picture of a not linear pair. What makes the linear pair and the other one not a linear pair? What do you think is necessary for angles to be a linear pair? Adjacent, connection, touching, those are all good words that you use. So a linear pair is both adjacent and supplementary, and not a linear pair, they could be supplementary, but they're not adjacent. So linear pair, adjacent, and supplementary. Now, you already have linear pair on your vocab sheet, so we're not going to write the definition down, but we are going to write the theorem down. So you've got the vertical angle theorem in your notes, and now you're writing the linear pair theorem. If two angles form a linear pair, then they are supplementary. Both of our theorems today are if-then statements, hypothesis and conclusion. Cross braces help keep the deck post straight. Find the measure of each angle. I'm trying to put as many real-world problems in here as I can, because I think it's important for you to know that geometry is everywhere, and I don't just make up problems for no reason. So we've got a deck, and a lot of times they brace it with an X, with cross braces. That supports and keeps those vertical supports, keeps them steady. Now, when they do the cross braces, 4 angles are formed. If you know one of those angles, you know all 4 of them. I want you to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. Okay, we'll do angle 2 first. You are totally right. The measure of angle 2 is 146. But then it says justify your answers. And we don't just breeze through that. We don't just ignore it. We do need to. The measure of angle 2 is 146 because of the vertical, I'm going to write it out instead of everything, vertical angle here. Okay. What about the measure of angle 1? What's the measure of angle 1? Good. 36 degrees. And how can I justify that? There you go. Okay. Because of the linear pair theorem, which says that if 2 angles form a linear pair, then they are supplementary. The supplement of 146 is 36. Yep, and then angle 3 would be 36 as well. Sorry. And you could cite the linear pair theorem or the vertical angle theorem for number 3. You could use either one now that you have both of those angles. Okay, let's move on. Given the measure of ABD is 3x plus 4. So this angle right here, 3x plus 4. And the measure of DBC is 56. Find x and the measure of ABD. So first step 1, identify your angles. Identify yourself. What angles do we have here? What's the vocab word? They're adjacent, but they're more than that. They're a linear pair. Yep. So we know the angles we were given are a linear pair. So we get to use the linear pair theorem since we know they are a linear pair. The linear pair theorem says they're supplementary. Very good. We know when angles are supplementary, their sum means add them together. Their sum is 180. The rest is algebra. Very good. X is 40. And then we could plug it back in, or we could just do 180 minus 56. We have choices. What would we get? 124? The measure of the angle? 124. Let's try another one. Given the measure of GHJ is 2x, and JHI is 3x. Find the measure of LHI. Ooh. When you're given a problem like this, I want you to first identify the angles, then solve for x, and then when you've done all of that, then you're allowed to try to find the angle you're trying to find. Don't try to find LHI yet. And don't say it's 2x yet. Okay, so identify yourself. What angles do we have? It looks like we have a linear pair again, right? So we're going to add these to equal 180. Sure, go for it. All right, x is 72. But that's just half the battle. It's asking for LHI. What do you think? So far, we've used the linear pair theorem. Oh, sorry, x is 36. Oh, you put LHI as 72. Okay, you're giving it away. X is 36. So then what we want to do is go to our picture. This is LHI. We know that that is vertical angles with GHJ. Those are vertical angles. So we can use the vertical angle theorem, which says if I know GHJ, which I do, 2 times 36, then I know LHI. So we use the linear pair theorem and we use the vertical angle theorem all in one problem. Good. Last problem of the day. The complement of an angle is 3 times as large as the angle. Find the measure of both angles. So what I recommend here is draw some complementary angles. You can make them adjacent to each other, or you can make them not adjacent to each other. It doesn't matter to me. Take one of those angles and name it x. Take one of those angles and name it x. The complement is 3 times as large. So the complement of angle x, I'm going to call it 3x. So call one of them x, call the other one 3x. Can we solve this now? We know that these are complementary angles, and there's not really a theorem for that, but there's a definition. The definition of complementary angle are angles whose sum is 90. So what's x here? Yes, 22.5. And the other one, 67.5. Yes, the measure of angles can be a decimal. Yes, the measure of an angle could be a fraction. Okay, I know I said that was the last one. If you can stay, I just want to go over this true-false real quick, because this is really good. Vocab practice. True or false? Angle 5 and angle 8 are congruent. What do you think? I'm going to go with true. Very good. And what's the reason? Vertical angle theorem. Right? Okay, next one. 4 and 7 are a linear pair. Let's think. Linear pairs, both adjacent and supplementary. Are 4 and 7 adjacent and supplementary? They're not adjacent. Okay? Very good. 1 and 3 are complementary. What are they? Supplementary, right? False. 1 and 4 are vertical angles. True. There's no theorem for that. That's just a definition. And 5 and 7 are supplementary. 5 and 7 are a linear pair. And if two angles form a linear pair, then they are supplementary. So very good. That is the linear pair theorem. You guys have a great afternoon.